it's Miss Miklos, and in today's lecture we are talking about parabolas. There we go, parabolas. And we've worked a ton with parabolas before, but today we're really focusing on some more specific characteristics on how a parabola is actually graphed. Okay, we know that the general function of a quadratic equation, f of x equals ax squared plus bx plus c, is a parabola that opens either up or down. And to be more specific in our definition here, it says a parabola, let me actually zoom out slightly. Perfect. There we go. Okay, a parabola is all sets of the points x, y in a plane that are equidistant, which means equal distances, from a fixed line called the directrix and a fixed point called the focus that are not on the line. The midpoint between the focus and the directrix is the vertex, and the line passing through the focus and the vertex is the axis of the parabola. Okay, so basically the way that a parabola is formed, I know we've just randomly graphed them previously, is based on every single one of these points. So here we have a point here is the same distance away from the focus to what we call the directrix. So that's this line. This point xy is the same distance away from the focus as it is from the directrix. So that's how all of these points are formed. Now, some things that I really want to stress to us is that the directrix is always a line, and so we need to write the equation of that line. It's either going to be a horizontal line or a vertical line, depending on the orientation of our parabola. It is always outside the parabola, so it's always outside the parabola. The parabola never intersects this directrix. Secondly, the focus is a point that is inside the parabola. Okay, so if the parabola opens up, the focus is moving up from the vertex. If our parabola opened down, to get to our focus, we would move down from the vertex. So the way that we can find the distance from the vertex to the focus and the directrix is d, so the distance away from the vertex to either the focus or the directrix is d equals 1 over 4a. Okay, so this is something new that we need to have memorized in order to be successful. So if we look, this is stuff that we have for the most part already learned. Okay, we have two different types of equations. One thing that's a little bit different than the way we wrote these in Algebra 2, you'll notice instead of having a plus k back here, it says the quantity y minus k equals a times x minus h squared. Our book writes it like this, and the thing I like about it is that it reminds us that we are always taking the opposite of these values. So whenever we see parentheses, we think we take the opposite. Okay, just some things for us to remember. If x is inside our parenthesis, that means that this value is our x value. If y is inside the parentheses, that means this value goes to be our y value. If it is a y equals parabola, I always think of that as going up and down like the y-axis. So if our a value is positive, it's going up. If a is negative, it's going down. The width depends on this a value as well. A normal width is when this is the absolute value of a is 1. So that means we would graph it. For example, if it was up and normal, we would go up 1 and over 1 in both directions. If this is greater than 1, we would call it skinny, because if we're comparing it to a normal graph, it looks skinnier. And if the absolute value of a is less than 1, we call it fat. And I like to think of fatty fractions. And obviously not every fraction is less than 1, but fatty fractions can just be a good reminder to us. Okay, the axis of symmetry is x equals h. Now the two new things are the focus and the directrix. If it is a y equals line, our focus point is h, comma, question mark. And we said the way that we find that question mark is doing 1 over 4a. The directrix is y equals blank, and we would find that by using 1 over 4a. Okay, notice my directrix line is a y equals, my axis of symmetry is an x equals. These will always be opposite from one another. Our second type of parabola is sideways. So this means our vertex this time, x is in this parenthesis, so this is our h, and y, that would give us our k. Instead of going up or down, since it's x equals, it would go right or left like the x-axis goes. So it opens to the right or it opens to the left. Our widths are exactly the same as a regular one. Our axis of symmetry, y equals k. And just a reminder what an axis of symmetry is. It's saying if I folded on that line, our parabola is a mirror image. It is symmetric on that line. This time, the focus point, we are going to find the x value and the y value staying k, and our directrix line is going to be x equals. I really want to stress these last two characteristics because historically students have struggled with that, and I just really want to make sure that we do well on this lesson. Okay? We need to memorize 1 over 4a. It gives us the distance from the vertex to the focus point or the vertex to the directrix line. So just like last class, we're not going to go through a ton of examples because it's pretty repetitive. Okay, we're really just going to highlight one from each section. So the first example, this is something new to us. It says, find the standard equation of a parabola with a vertex at the origin. Okay, so I'm going to just make a little note to myself. The vertex is 0, 0, and the focus is 0, 4. Now, my big hint to you guys for this entire chapter is even though this is not asking us to graph, when in doubt, I want to go ahead and sketch a graph if it helps me out. Okay? So sketching a graph sometimes will help us learn some information. And what's going to happen here, okay, 0, 0 is the vertex. 0, 4, so I'm going to go up 1, 2, 3, 4, is our focus. We said earlier that the focus, and let me just write V and F here, the focus is always inside the parabola. So what that means is that my parabola has to be going up. Okay, if I graphed it any other way, it would not be inside our parabola. So up is the only thing we could do. Now with this knowledge, I know two things. I know it has to be a y equals parabola because I know y equals parabolas go up and down. I also know that the a value has to be positive. A is greater than 0. And the reason why I know that is because the parabola is going up. So since I know those two things, I can write out my general formula, y minus k equals a times x minus h squared. Yes, we need to have those formulas memorized. So it tells us that the vertex is at the origin, so I'm going to go ahead and put in y minus 0 equals a times x minus 0 squared. So I really get y equals a x squared. And at this point, we might be a little bit unsure, how do we find this a? Okay, so we're going to rely on the information given to us. I know the vertex is 0, 0, the focus is 0, 4, so that tells me that this distance is 4. Okay, the focus is 4 spots away from the vertex. So earlier, I mentioned the fact that the distance that the vertex is from either the directrix or the focus is equal to d equals 1 over 4a. Now this one's kind of strange because we know the distance right away. We know the distance is 4. I have 1 over 4a, so when I multiply, I get 16a equals 1, so a is 1/16. Now I know that a should be positive because our graph was going up, so the equation of this particular parabola is y equals 1/16 x squared. Okay, now if our vertex was somewhere else other than the origin, then obviously that would change where we would put h and k. It would change this distance as well. Okay, but based on this information, these are the steps we would have to take. Okay, if they gave us the directrix instead of giving us the focus, we know that the directrix is always outside the parabola. So we would have to draw the parabola in the way that it would not intersect the directrix at all. Okay, second major concept, it says find the vertex, focus, and directrix of the parabola and sketch its graph. It is so drilled and ingrained in our brains to find the four characteristics. And the reason why we made you guys do that in Algebra 2 is really to have an understanding of what this graph looks like. Now, we only need to find three things here. We just need to find the vertex, focus, and directrix. But we really need to find all that other stuff too because we need to sketch it. We're just not necessarily going to write it out. So looking at this, the very first thing that I want to do, I want to have our non-squared variable have a coefficient of 1. Okay, so I'm going to divide both sides by 3. So I get 1/3 y squared equals x. So looking at this, I'm going to go ahead and write out our three characteristics. I know my vertex is 0, 0, because I don't have a number here. I do not have a number inside a parenthesis. So our vertex is 0, 0. Since this is an x equals equation, I know that it is either going right or left. 1/3 is my a value, and if you guys wanted to, we could flip this and write it as x equals 1/3 y squared if that makes it easier for you. Okay, so 1/3 is my a value. That is positive, so I know it's going to be going to the right. And I should actually label this that this is our vertex. So I'm going to kind of sketch this as we talk about it. Okay, here's my vertex. So I'm saying based on this 1/3, it's going to the right and it's going to be fat because it's a fatty fraction. So here we go. So to graph this, it is just a sketch. So I could go to the right one and up 2, and to the right one and down 2. I could go up 3 and down 3. That would be correct also. It is just a sketch, okay? It's not exact. Now, the final thing that we really need to do here is determine what is the focus, what is the directrix. So I'm going to use that formula, D equals 1 over 4A. Notice we actually know what A is this time. I know that A is 1/3. So D equals 1 over 4/3, which would be like 1 times 3/4, which is 3/4. So this is how far away both the directrix and the focus are going to be from the vertex. Since this is going to the right, we said the focus is always inside the parabola. That means I have to move over 3/4. So we get an ordered pair of 3/4, 0 as our focus. Now to find our directrix, I'm starting back at the vertex and I need to move outside the parabola. So the only way that I can move it so it does not intersect our parabola is by moving it to the left. Okay, so I'm going to move over -3/4, and I'm drawing a vertical line. So our directrix here would be x equals -3/4. And that is the equation of our directrix. Okay, so these are really the two new things that we're learning. Everything else you guys have done before. Okay, focus is always inside the parabola, directrix is always outside the parabola. Notice they are the same distance, they are equidistant from the vertex. So let's do another one for B. Okay, B looks a little bit confusing because I notice that I have an extra x in here. So we talked about this with circles. That means I am going to need to complete this square. Okay, so I'm going to group my x's together, and I'm going to move my other stuff over to the other side for the moment here. Okay, so I have x squared minus 2x. I'm going to take that -2, divide it by 2, and square it. So I'm going to add 1 To balance it, I have to add 1 to the other side. So this would become x minus 1 squared equals negative 8y minus 8. Now, to finish this, I notice that I need to get, well, there's really a few ways we could think about it. I could factor out a negative 8 from both of those terms, and then divide both sides by negative 8. So I get negative 1/8 times x minus 1 squared equals y plus 1. We could have also just divided everything by negative 8 right away and not factored it out, and we would get this same exact equation. And the reason why I needed to get rid of this negative 8, just like in our previous example, I need my non-squared variable to have a coefficient of 1. Okay, so I had to get this y value to have a coefficient of 1. So now that we have this, and if we wanted to, we can change the order so it looks exactly like our general equations. It's saying the same thing. First thing we need to find is our vertex. Our vertex, x is connected to this negative 1, so positive 1 is the x value. Positive 1 is connected to the y, so negative 1 is our y value. So our vertex is 1, negative 1. We know we also need to find our focus and our directrix, but I'm going to go ahead and graph this first, because in order to determine what the focus and directrix are, we need to know what direction are we moving in. Okay, so here's 1, negative 1. If we look back at this, since it's y equals, I know it's either going up or down. This negative 1/8 is telling me it's going to go down, and the 1/8 is telling me it is a fatty fraction. So, when graphing this, okay, we said it's down and it's fat, so I'm going to go down 1 and over 2 in both directions. And our parabola is going to look something like this. Now this time, since my parabola is going down, it's opening down, I know my focus needs to move down from our vertex because it needs to be inside. Our directrix, on the other hand, is going to move up from our vertex because it needs to be a line that is outside the parabola. So I'm going to go ahead and do d equals 1 over 4a. Okay, this time our a value was negative 1/8. So I get d equals 1 over negative 1/2, which would be negative 2. Notice this negative 2 actually is telling me to move down. Now normally with this d, we kind of disregard negatives because we know direction normally is not negative. It's always a positive value, and we can just say move up or move down. Okay, but if you left it in there, it's not wrong. So what that means, and we can do this mathematically and just like change this ordered pair. For me, it is much easier for me if I do it visually, okay? And I'm not even that visual of a learner, but I just think it's easy if I go, okay, down 2, and I put that point, and I can see, okay, that point is 1, negative 3. Now, the other way we could have done it, and some of you guys learn this way, if we see the vertex is 1, negative 1, if I know I'm moving down 2, that means that I'm subtracting 2 from the y value. So negative 1 minus 2 is negative 3. So either way you do it is totally fine. Okay, for our directrix, I'm moving up 2, so I'm going to draw a horizontal line. And I can clearly see that that is at y equals 1. So that would be the equation of our directrix. So once again, those are the things that you guys really need to practice because they do take a little bit more time. And our last example, this is another finding the equation of the parabola. So once again, our tip, when in doubt, sketch what you know. So I'm going to start by sketching here. It tells me that my vertex is at 1, 0, and our focus is at 2, 0. So what that signals to me, I know that my focus always needs to be inside my parabola. So that means that my parabola is opening up to the right. So that tells me that it's going to be an x equals parabola, and our a value is positive, or I could write a is greater than 0, either way. So I'm going to write x minus h equals a times y minus k squared. So I'm going to substitute in what we know. We know that the vertex is 1, 0. So I have x minus 1 equals a times y squared. So I'm going to go ahead and we need to determine what is this a value. So once again, we know d equals 1 over 4a. We can see that this distance right here, and I'm even going to draw on it, is 1. The focus is 1 away from our vertex. So I have 1 equals 1 over 4a. So 4a is 1, and a would be 1/4. So my final answer would be x minus 1 equals 1/4 times y squared. Just to double check, I know this 1/4 should be positive because my parabola is opening up to the right. So this would be our final answer. Okay, so even though we don't have a ton of examples here, hopefully you guys are seeing how we have to process through these new concepts that are handed to us. Okay, so in addition to what we've previously learned about the parabola, we really need to know about the focus and the directrix.